Hi,
All
folks.
right.
Time for chemistry.
Yes.
This is podcast 2.6, and we're working on density today.
Density and specific gravity.
Right.
All right. Get
Okay.
your calculator ready.
Yes.
We're going to do a lot of calculations.
And another thing you're going to need is your staircase. That metric mania notes.
King Henry.
Yeah. We're going to use King Henry's way to solve a few problems.
Yes.
All right. First, let's look at density in particular. This is one of those intrinsic properties of matter.
Properties. I remember that.
Right, and it's useful for us to identify what kind of substance it is, because it's the ratio of the mass of an object to its volume. And this ratio will not change as long as that object stays at the same temperature.
Yeah, even if you're going to cut, if you're going to cut a piece of that metal, it will change the mass, right?
Right, it will change the mass and it will change the volume, but the ratio of mass divided by volume is going to be the same. Yeah.
That's what I'm talking about.
And here's that mathematical formula.
Okay.
By ratio, we mean dividing. That's like a math word.
It simply means density equals mass divided by volume.
Yes. And one of my students last year taught me about the fox. If you want to know the density, you ask the fox. See, it looks like a fox with his ears here and his nose down here. There's our fox.
Okay.
M over V.
Yeah, that will help.
Yeah. I'm not a good fox drawer, apparently.
Yeah, me too.
Okay. So now, let's look at the units for density. For mass, we use grams.
Okay.
And for volume, we use milliliters. And so we could write our units as grams per milliliter. Or, since a milliliter is the same as a cubic centimeter,
or grams per cubic centimeter.
Grams per cubic centimeter. Okay. And if you're in the medical field, they call cubic centimeters cc's.
cc, okay.
Yeah. We don't use that in the metric system.
Okay.
It's centimeter cubed.
All right.
All right. It's the same quantity. Great. Let's look at an example.
Oh, we're in an example already?
Yep, let's do this. Here's what I want my students to do when we have a math problem. Yes. Underline key terms. A copper rod has a mass of 0.52 grams.
I call that the given quantities, right?
Right. And let's go ahead and write that down. M is equal to 0.52 grams.
Okay, write this down, guys.
Yep.
Follow Ms. Gray.
Then it says the volume.
Volume. Was
determined by water displacement to be 0.05.
And we talked about water displacement.
Yes, right. We did. How to measure the volume of an irregular object.
Yeah.
Okay, so 581 milliliters.
Okay.
Okay, so it's a very tiny copper rod. It looks like about the size of a straight pin. Yeah, so really tiny.
Very tiny.
Yeah. What is the density of this copper rod? Okay, so even though it's just a tiny piece,
we can still...
It should have the same density as any piece of copper.
Yes.
All right, what's our formula for density?
T is equal to M over V.
Right. Talk to the fox. M over V.
Yes.
So the ears and the nose, M over V. So now that we know what the mass is and what the volume is, we're going to put this number in for the mass and this number in for the volume.
All right. So that's 0.52. I bet that's divided by 0.0581.
Good. When my students set this up, and yours too, I want you to put units in there.
Oh, yes, of course. Unit is very important.
Yes, so put them into your calculation, not just in your answer. That way you can check to see, am I doing it right? You should have grams over milliliters, not milliliters over grams. Okay, so put in the units to make sure you're doing it right.
Yes.
And what answer did you get?
I got 8.95.
8.95.
How many?
Grams per milliliter. Let's check sig figs, because our students have by now listened to that podcast. This one has 2, and this one has 3. So our answer is limited. We're dividing, so it goes with the least number of sig figs.
Least number of sig figs.
We're limited to 2 sig figs. This 5 is big enough to change the 9 to a 10, and that means that goes up.
9.0.
Yeah. So that's pretty close to the density of copper. Yeah. It's not exactly the density of copper, but that's because there's always experimental error.
Yes.
Okay.
So our final answer is 9.0 grams per
milliliter.
All right.
I had a big sneeze. Okay. So then we put that in a box because that's our final answer.
Yes.
Yep.
Follow that.
Great, that doesn't seem too bad. Let's try another. In this example, we have 1.60 liters, so that's a volume, right? Because it's in liters.
Yes.
And it's tin 2 fluoride that has a mass of 2.59 kilograms. So this is a much larger sample, right? I'm going to write these down.
Write the given.
Yeah, our volume was 1.60 liters. All right, now King Henry will show us how to change liters to milliliters.
Yes.
Yeah, get your King Henry notes out. So we're going from liters
to
milliliters. And so that's 3 steps.
3. Yes, 3
to
steps.
The right.
To the right.
Okay, so 1, 2, 3.
So that's going to be
1600 milliliters. All right. Now let's do mass.
That's 2.59 kilograms.
2.59 kilograms.
And we want that in grams, right?
We want that to be in grams. So start at kilo and go to grams.
Kilo to grams. According to King Henry, it's 1, 2, 3.
3 steps to the right again. So
yes.
2.590 grams. Okay. Since we moved them both 3 steps to the right, we went the same direction for both, then we didn't have to do anything at all to these numbers to get them to be grams per milliliter.
Yeah.
Kilograms per liter is the same thing as grams per milliliter. Okay, because we did the same thing on top as what we did on the bottom, and that would ultimately cancel out. Because we're dividing 1,000 divided by 1,000.
Yes.
Right? So we didn't have to, but we wanted to make sure we got the right units.
Yes.
Grams over milliliters. So we talked to the Fox. Density is mass over volume. So we take 2.590 grams.
Divided by?
This is why I'm putting units there, to make sure I put the right thing on top.
Yes.
Divided by 1,600 milliliters. And what you get?
And add that will give me 1.61875.
Okay.
Let's write down the whole number first.
Yeah. Should we keep all of that calculator vomit?
Let's try to count.
Let's see. Do we count this 0 as significant? If it follows a digit and a decimal?
Yes, it is.
Right. So that has 3 sig figs.
That's 3.
And this has 3 because no zeros.
Yeah.
So 3 sig figs in our answer. 1, 2, 3. That 8 is going to make a difference.
So final answer is 1.62 grams per milliliter.
Good. Put that final answer in a box so that it's easier for us to find.
Yes.
Great. So that's how we do density problems. Now let's use density to solve another kind of problem.
All right.
All right.
Is this complicated, Ms. Gray?
Nah. We just have to write down our givens.
Okay.
And we'll have a strategy.
Right.
This now is asking what is the volume. So this is our target. What's the volume? Here's our mass. Because it's in milligrams. So mass is 7.4
times 10
times 10 to the third milligrams. Okay, get your King Henry table out.
Yes.
We got to change this to grams. Okay. So we're going from milli to grams.
Where's my milli? Right here?
Yeah.
To grams. So 1, 2, 3.
To what direction? Left or right?
To
left.
To left.
1, 2, 3. Okay. So I have 0.0074 times 10 to the third grams. Okay. We moved 3 times. We could just get rid of that.
Oh, yeah?
Yeah. But let's do that. So 7.4, right?
Yeah.
Let's check this on your calculator just to be sure. Do 0.0074.
0.0074
times 1,000.
Times 1,000? 7.4. Yes, you're right.
Okay. 7.4 grams. All right. So that's our mass. And then we have our density.
Density.
Is given.
Oh, given is density, Ms. Gray.
Yes.
The last 2 problems ask us about density.
Right. So now we know what the density is. Hey, there's our copper density. We got 9.0 last time, remember?
Close.
Yeah.
Pretty close.
Okay, and now we need to find the volume.
The volume.
Well, I don't know the formula for volume, but I know the formula for density.
Density is
Talk
mass
to the
over
fox.
talk to the fox.
Yeah, mass over volume. And so let's rearrange this. Okay, I want to get volume by itself.
Yes.
So I need to get it out of the denominator. What's the opposite of divide?
Multiplication.
Okay, so let's multiply both sides by volume. And that way I can get it out of the denominator.
Yes.
So now I have volume times
Times
density equals mass. Okay, so now I want to get V by itself. I have to get rid of density.
Density, so divide both sides by density.
Okay, good. So volume is equal to mass divided by density. Okay, now in math class, some of our students remember they learned you can just switch places with these two. And that would...
Oh, yeah, that's easy.
Yeah, and some of them have done the triangle thing before.
Yeah.
Where mass is on top and then density and volume are on the bottom.
Oh,
yeah. So if that works for you, use it.
Yeah.
Okay.
Whatever works as long as you're going to get the correct one.
Yep. So now let's go solving for volume. Is mass over density. So
7.4.
7.4 grams divided by 8.92 grams per cubic centimeter. Notice now I have a fraction in my denominator.
Yeah.
Let me show you how this math works. We're dividing these two. Grams over 1, right, divided by grams over centimeters. And to divide fractions, we do copy dot flip. So grams times flip. Centimeters on top now, grams on the bottom. So grams are going to go away.
Yes.
And that leaves us with cubic centimeters. And those units make sense for volume.
Yes.
That should work. What number did you get?
It's 0.892. It's a very long number, but
892 blah, blah, blah. Because I've got 2 sig figs in my first measurement.
So that will give us...
So we can drop this too. So 0.89 cubic centimeters. That's a big mess. I'm going to write it over here. 0.89 cubic centimeters. And then I'm going to put a box around it so my teacher can find it.
That's the final answer.
Yes, because we evaluated sig figs and our units are right. So now we've got it.
Yes.
Good. That wasn't too bad either. We just had to rearrange the formula.
Yes.
And that took some algebra.
And whatever works for them.
Whichever
matter.
method.
Yeah.
Yeah. All right. Okay. Just show us your work. Now let's do another one because I added an extra bit of information to this question.
All right.
Okay. We have a beach ball and it has a volume of 21.8 cubic centimeters and a mass of 16.1 grams. So those are our givens. Let's write down our given information, 16.1 grams.
Always start with a given, guys, please. Don't be so lazy in writing down. That will help you a lot.
And then density, what was our formula?
Is equal to mass over volume. Ask the fox.
Yes, talk to the fox.
Talk to the fox.
Okay, density is mass over volume.
Oh, there you go.
So I think we're ready to solve for the density of the beach ball.
Yes.
Let's put in our mass, 16.1 grams.
16.1.
Divided by 21.8 cubic centimeters. What you get?
That's good. That gives me a lot of numbers. 0.7385. Blah, blah, blah.
Okay. And I have grams over cubic centimeters for units.
Yes.
Let's see. 3 sig figs here.
And 3.
3 sig figs there. So 1, 2, 3. Yeah, we better round up. 'Cause that's
0.739.
Yeah.
Okay.
Now, if we answered the question they asked.
Would this ball sink or float in water? What are we going to do with that? How are we going to know if it sinks or floats in water? We need to know the density of water.
Yep, we have to compare this to the density of water.
Yes.
Okay, and liquid water.
Liquid water.
Right. And that's always going to be equal to 1 gram per cubic centimeter or gram per milliliter. So that's pretty easy to use for comparison's sake.
Yeah.
Density of water is 1. And if you have greater than 1, it will sink.
Yes.
And less than 1, it will float. So let's look at our density. We have 0.739.
That's less than 1, I think.
So our answer is the ball
is going to
float. Yeah, it's less than 1.
I think you're going to observe that if you're going to the beach, Miss Gray.
I think so. If your beach ball sinks, it wouldn't be much fun to play with.
Yeah.
Right.
That will not help you. Like if you don't know how to swim, like
yes, right.
I need a beach ball.
Yeah, you have to have something to float that you can.
I don't know how to
hold
swim.
on to. So now
that's my secret. Okay.
Not secret anymore.
Yeah.
All right. Now I was going to ask you something. Oh yeah. What if I had put a box around this and only given you this part and not this piece?
You miss one of the answer.
Yeah.
It's not the answer.
Right, I didn't answer the question.
Yeah, it didn't answer the question because it says, will this ball sink or float in water?
So do make sure that you answer the question we ask, not the question that you wanted us to ask.
Yes, exactly.
Yeah. All right, let's move on and talk about specific gravity.
Specific gravity.
It's closely related to that density of water because for specific gravity, we're going to compare the density of one substance with the density of a reference.
Example of a reference density, Ms. Grace.
The most common reference is water.
To water.
Yeah, we compare the density of one thing to the density of water at 4 degrees Celsius because that is in particular when water is equal to 1 grams per cubic centimeter.
Okay.
When it's at 4 degrees.
4 degrees Celsius. Yeah. Okay.
And then once it goes below 4 degrees, it starts getting less dense. That's why ice is less dense than water and it floats on top.
Yes.
It's a good thing. Or life in the oceans could not exist when it gets really cold. If it froze from the bottom up.
Yes.
So the formula for specific gravity is really simple.
Very simple.
You take the density of your substance.
Divided by the density of water.
Right. And the density of water is 1. And so whatever the density of your substance was, like in copper, 8.92, you guys don't need a calculator for this math. Right. And look at our units. We'd have grams per cubic centimeter on top, grams per cubic centimeter on the bottom. A number divided by itself is equal to 1. It just goes away. Yeah. So this is easy math.
And so meaning to say, Ms. Grace, specific gravity does not have unit.
That's right. Okay. It's the only unitless quantity that we're going to use.
There you are.
Right. And boy, this is the easiest calculation we're going to ever ask them to do. Divide something by 1.
Okay.
And don't use your calculator.
I don't even need my calculator. I'm going to
not for this.
Keep that away.
Yeah, except for finding the density of something first, right?
You might need that.
Get it back. Okay. Let's do one. The chunk of granite. See, geologists use specific gravity a lot to talk about rocks.
It's not only in chemistry, huh?
No, it's in geology a lot. So here's a mass. I'm going to write that in my given.
Write down your given, guys.
31.2 grams for my chunk of granite, and it displaces 11.8 cubic centimeters. That's volume.
That's the volume.
Yeah, because it's in cubic centimeters.
Yeah.
Okay, what was our formula for density?
D is equal to mass over volume.
Right, talk to the fox.
Yep.
Okay, 31.2 grams.
I need my calculator.
Yes, I'm glad you still have that out.
31.2 divided by 11.8. That will give you 2.64
grams per cubic centimeter.
Yes.
Is that all the sig figs you have?
I think so.
All right.
Look at the given, yes.
Yep, 3 here and 3 there. Did we answer the question they asked?
No. Because that's density, not the specific gravity.
Right, we want the specific gravity. So we take the density of our granite and divide by the density of water. And so I'm going to write out this step, 2.64 grams per cubic centimeter divided by the density of water.
Which is
1.00 to be precise.
Yep.
Gram per cubic centimeter. Okay. And
cancel out the units.
Units go away.
Yep.
And our math, do you need your calculator? I hope not.
I don't need my calculator.
Okay.
I can do it in my head, Miss Gray. Let me think. 2.64 divided by 1 is equal to 2.64.
I wrote it before you said it. I was being impatient.
Okay.
Because it's really that easy.
I know.
So our students will try to make this harder than it needs to be. But we'll just get to point and laugh because we told you so.
I know.
Yeah.
Yes, exactly.
All right.
2.64 is the answer.
And that's it. That's all there is to density and specific gravity.
That's easy.
Yeah, you guys can do this.
I hope you guys enjoy.
Yep, we're going to do a density lab in class, so we'll see you next time.
All right.